Hello, welcome again, everybody. I was asked the question, which meter should you use to measure current? Now, let's first, before we go to these things, I wanted to go over one thing. We all know there's modules all over now in electronics, automotive today. That's the reason, obviously, for my channel. Now, this is from over here. You can see a printed circuit board that I have in my hand. It's a lighting control module. Now, this is used to control the lighting. Now, I want to show you something. First of all, the boards that are placed in the car, there's a reason for everything. You have to understand the car is getting hot, especially when the hood is closed in summertime with the compressor on. Heat is a failure for these type of boards, number one. The other thing is vibration. So you have to consider, or the engineers consider, that that car is going or being driven 80, 90 miles an hour, going over potholes, hitting bumps. Now, where are you going to place these type of boards? So the thing is, the big computer, usually you see it by the struts, and it's on the top under the hood. Now, like I just said, there's vibration. On that one, there's a heat sink, and I'll show you when I make the video. There's a big, huge heat sink. For the reason being obvious, a lot of heat is being dissipated in that PC board, that module that we call it. So a heat sink takes away the heat from the components, from obviously being destroyed by heat. Now, some boards like control modules, fan modules, or other modules, they're by the dashboard. So still, now you're going to ask the question, where should we put these type of modules so vibration is not a factor? Where the whole car vibrates. It's hard to find a place that is not prone to that. So I just wanted to show you, and before you understand what's going on, this is the connector that it's connected to. Okay, and by the way, when you put the connectors, doesn't matter how many connectors there are, make sure you are secure in that connector, because that connector comes off with vibration. You're going to have problems with modules. Fans not working as I had, just for the simple reason that the connector was not made good contact. Okay, so make sure, take the connector and make sure, tug on it is the word, to tug on it. Okay, now, usually the problems that I had always with these things, you have something called through hole. These are through hole resistors. This is a dental pick that we use. Now, this is how we solder these type of components. Some are called, over here, through hole. This is the connector. These are called through hole, over here. The other ones on top of it are called surface mount. These are the components that are prone to vibration. So, as you see, let me try to get a close-up. You see these pins over here with the dental pick. These pins have a tendency to lift up and not make contact on the pads. They have to be resoldered, which I do usually on many occasions to these type of boards. They have to be reflowed, like they say. So these are the problems. The instrument panel that you have, the dashboard, giving you the gauges, I used to work on those. Those have these type of pins, even more, and these used to come off all the time. We had to reflow them. So I just wanted to give you an example of what a printed circuit board looks like, a module actually looks like. So be careful with these. Make sure they're plugged in correctly. Now, going back to the point that I said originally, right? How do you measure current? Well, we went over a DC voltage. I made a video, but I don't think it was too good. The light quality was not too good. Let's use the same meter like we did before. Okay, obviously we said the probes that we use always go into this one, voltage and ohms and diode test. Okay, what's the first thing that we do? Let's recap. First thing we do before we even measure voltage is we have to make sure that these test leads are not broken internally. How do we do that? We short them together. Okay, what should we expect? That's what we should expect. Close to zero as possible, 0.2. Okay, if we're like this, the numbers are going up and down, fluctuating. What's the reason? These are not good. Change these. So we're very good with these. As you can see, 0.2 is fantastic. Now, we go to the voltage. Which one do we go to? We want to see DC volts. And we went over why, which one this is DC volts. The flat one is the DC volts. So just do the minimum. Like we said, we want just a usual battery. How much should we measure before? We should not measure 1.5. We should measure higher because there's no load attached to it. We should measure, as you're going to see, 1.6. There's no load. When you put a load or you put it in the radio, it'll go down to about 1.5. Okay, that's that. So we went over that. Now, the voltage over here, if you want to put it in current, to measure current, there's a problem. When we measure current, we have to take out the component, or we have to break the trace, so to say, and put the meter in place of where we broke the trace or the wiring, or we took out the component. So in other words, let's say we want to measure the current through this resistor over here. Regular resistor, right? We can take out the resistor over here. We can break the plane, the connection over here to where the resistor goes. That's too much work, obviously, as you can see, especially on a printed circuit board. Okay, so that idea, not the best of ideas. Okay, you could do it with the battery terminals, yes. So what I'm saying is, anytime that you want to take a circuit, any circuit, you have to take something out, break it, and put these two leads in it, and put this on the appropriate setting. Okay, so that's milliamps or amps. All right, and so too much hassle, too much work, and too many problems with that possible. Right? What's the other problem? We have to figure out how much amps the circuit is using. That's the first thing you ever do. How do I know how many amps the circuit is using for a blower motor, fan motor? You'll say, I'm not the engineer, I don't know. You know by the fuse. Go to the fuse. If the fuse is rated at 30 amps, that's the most that you can take from that circuit. You can pull from that circuit. So 30 amps is the most, right? But it'll blow the fuse. So don't go to the fuse. If it's blown, you have no even reason to go and measure with an ammeter, because it might blow the ammeter. Number one, you have to know how much amps the circuit is requiring. If it's a 30 amps, so let's say it'll take about 25 amps. Anyway, not to bore you, but anyway, the rating is very important. Why? And this is why I'm getting to the whole thing of why you go the proper meter. Let's say I need 30 amps, right? We come over here and we look at it. Hopefully you can see it. Let's take this away. What does this say over here? It says 10 amps, not good. Cannot use this meter. That's a problem. Okay? Problem, I don't want to break the circuit. I don't want to take the terminal cables off the battery. No, I don't want to do that. Right? So, this is the one you always saw me use this in every single video. This is the best company doing these things, CE. It's called CE, as you can see. Look it up online, and they make many, many meters and power supplies. They're famous for these things. Comes along this one, like I told you, we don't want to do this. We don't want to take anything out. What we want to do, you see this wire? This is for hard wiring. Wherever there's a wire, a harness, or a battery wire, all you do is just put it around. This has, whenever a current goes through a wire, a magnetic field is created through that wire. This senses it, turns it into a current reading. So that solves part of our problem. We just said we have a 30 amp fuse. So maybe I'm drawing 25 amps. How do I know if I can still use this tool? This tool is 10 amps. He's out of the picture. Let's see how much is over here. We come to this setting over here. How much is this over here? How much is this setting? This goes up to 40 amps. This even goes up to 200 amps. Is that good? Oh yeah, it's good. Therefore, this is the proper tool to use. Okay? You turn it on. You put it on here. Let's look at the display that I've used so many times. You see this A over here? What does it denote? Amps. So therefore, see this A over here? This is better lighting. This is DC, and I'm on amps, so DC amps. If I want to be on AC, this is AC, still amps. Higher scale, oh, you can't see it, but okay, 200 amps. 200 amp AC. Want to be on volts? This is volts, this is DC. So I like these digital meters, like I told you. I want to see what I'm set on, what the selector is on. I don't like the ones that doesn't tell you which you're not selected on. If it doesn't have the DC or the AC, it doesn't tell you what you're on. I don't like those digital meters. I like this one. As soon as you put it to this, it tells you what you're on. So if on ohms, it tells you ohms, just like this one over here. So we said we could come out with this one. Question, let's say I want to go over the starter motor. I want to see how much I'm pulling, how much current I'm pulling. I could be pulling 300 amps on that big, huge, thick wire, that starter motor wire that you always see that goes from the battery to the starter. I could be pulling more than 200 amps. We said this goes up to 200 amps, correct? Will this do the job? No. Now he's out of the picture. What do we need? Come this one. The big jaws one, right? What do we need? We're going to use this one. And what is this rating at? 400 amps, up to 400 amps, up to 600 volts. DC or AC. So this one is the proper one to use over that starter, that wire going to the starter motor. This is the correct rating. Okay? Now, question. Let's review. We just said we have to use the proper tool, and that was the comment or the question that the rose came to me from that person. Which tool do you use? Use it for the right job. I want to measure current. Okay, let's say I want to measure a fuse. That fuse says 5 amps. Which of these meters that I just showed you, that I just demonstrated, can I use for 5 amps? If you said this one, you're partially wrong. Why? We need 5 amps. Remember I told you what this one goes up to? This goes up to 10 amps. This is good. This is good. And this is good. What's the answer to that question? They are all good. If I ask you the question, I want to measure 50 amps. Right? The fuse says 50 amps. Ignition. Usually they're 50 amps. Which meter can I use for 50 amps? He's out of the question. He's out of the picture. I could use this one. Which setting should I put it on for 50 amps? Put it on this setting, 200 amps. Can I use this one? Can I use this one? Yes. Okay? So I hope this helped a little. Use the right tool for the right job. Always first get the rating of how much current you're expecting. Work after that. Then figure out which meter I can use and know the capacity rating in current of each meter. Please go to my channel, Joe Electronic Schematics for Auto, and my other channel, my original one, Automotive Electronic Schematics for Joseph. You'll see many, many videos of diagnostics, and the one that I did in the relay of testing the relay in the circuit. That means I kept the relay in the circuit, and what I did was I just put a terminal inside of their wire and to measure the relay in action as it works in the relay. Please go to all those videos of relay, testing a relay in circuit, going to car fuses. I'll hope to make better ones also. But thanks for watching last night. Had a lot of minutes watched. I don't know, I very hardly the views are low, but the minutes watched are phenomenal. I don't know why. I'm at like 50 or 60% of each video, which YouTube wants. The views, I'm working on it. But anyway, thanks for watching. Thanks for giving me the minutes. Thanks for giving me, I guess, the 50%, 60%. Thanks for watching. Hope it was educational.